So, last time we were talking about portfolios, and we were talking about how it matters how these things move with respect to each other. And so the first thing we're going to do is we're going to look at a very simple portfolio composed of two stocks, and only two stocks. And this is going to teach us a whole lot about the way portfolios work. And we went through last time the different stages of the economy. We said there was depression, recession, normal, and boom. By the way, is it always going to be those four? No, sometimes they may only be 2 or 3 stages of the economy. But if you add the probabilities up for all of them, what do you think is always true? Yeah, it always adds up to 1.0 or 100%, so don't let that freak you out. In fact, you'll see after we get through calculating these, you would rather be working in a 2-state economy, right? Normal and boom or normal and recession, something like that, because it makes your work a lot easier. Okay, now let's talk about these two firms. We can see that for different states of the economy, the returns are different, and that makes all the sense in the world. The first one is Supertech. And in a depression, it loses 30%. You know that lose is a negative sign. Right? Lose is a negative sign. 30% is 0.30. In a depression, it loses 30% of its value. That makes a lot of sense, right? Because depression's a bad sort of time. Now, recession is going to lose 10% of its value. In normal times, the return is going to be positive 20, and in boom times, the return is going to be positive 50%. And so that's what we're seeing here. And in fact, what we would refer to this as is a normal or luxury goods company. I'm going to ask one of my economists. I'll start with Mr. Pullman. What is a normal or luxury good?
Like the difference? Well, they're different things, obviously. But
Well, no. So I think economic definition, they use these interchangeably. Let's just cover up luxury. What's a normal good?
something that everyone needs or will use on a normal basis.
Okay, now I'm going to try Miss Perry. Miss Perry.
Oh, I'm getting the same answer.
Oh my goodness. Okay, well let's go the other way. What's an inferior good?
Easy to substitute.
Okay. Okay, so obviously either I have totally forgotten all the economics I ever learned, or you guys didn't learn squat, so you need to get a refund on your tuition.
Isn't it inferior good as your income goes down, your demand for it goes up?
Whoa, she's on fire. Absolutely. I'm glad you came to class today. An inferior good is one that the demand for it goes up as times get worse and goes down as times get better. I'll give you an example. During the financial crisis, do you think people were buying luxury name brand stuff like Gucci and whatnot? No, everybody traded down. And so the people who were formerly shopping at Kohl's were now shopping at Target. We're talking for clothes. Shopping at Target, the people who used to shop at Target were shopping at Walmart. The people who used to shop at Walmart were going naked. And so if you look at the kind of clothes that they sold at Walmart, it's an inferior good. Not to say that it's of poor quality, but people just consume more of it when times are bad. Now let me give you another example of an inferior good. Cheap liquor. Cheap liquor. Why do you think people drink more during bad economic times? Stress. So they're trying to forget their troubles. I'm not recommending this path for you, but this is what people do. And so, but at the same time, do they have money to buy the good stuff? No. So there they are buying what's really nasty. Milwaukee's Beast, right? What's that?
Bush Light.
Aristocrat. I've never even heard of that.
Bush
Oh,
Light.
Aristocrat vodka. Yeah, okay. Totally misnamed, right? Because you think aristocrat sounds like a, okay. So now we understand what an inferior good is. If you had to guess, what is this other that we're talking about? Ms. Volkova, what do you think?
The normal or luxury is your demand for it goes up as your income goes up.
Yeah, your demand for it goes up as your income goes up. So what kinds of things might we include here? How about golf clubs, right? So during bad economic times, do you think people are like, you know, I really need a new set of clubs? Yeah. What about luxury automobiles? Yeah, it's a normal or luxury good too. In fact, it's not just the person whose income gets hit that reduces the sales of these automobiles. It's also what happens to their neighbors. I'll give you an example. This was back during the financial crisis. My neighbor Larry and his wife were out walking a new puppy. And I said, "Oh, the puppy's so cute. What's the puppy's name?" And his wife said, "The puppy's name is Audi, A-U-D-I." And I said, "Why is the puppy's name Audi?" And she says, "Because it's the car we always wanted, but now we know we'll never be able to afford." I had been looking at an Audi A4 at that point. What do you think I bought? Nissan Altima. Now, I look back on that decision and with regret. But why did I not want to drive home in an Audi? It's like rubbing it in, right? You don't want to display wealth when other people are hurting. So, do you see how that it's not just Larry whose income was down because of the recession, it's his neighbors too. And so you'll see a lot of these that are really sensitive to the change in, say, GDP. Okay, so if we look at SuperTech, can you tell me whether it falls in this category or this category?
Some luxury goods, some other goods.
Yeah, it's more like this right here. It's more like that. So it's a normal or luxury good. Now let's take a look at Slowpoke. In depression, 0% return. And you might say, well, 0 kind of stinks. Well, compare it to what's going on at SuperTech. Oh yeah, hey, recently I would have loved to have 0% return on my investments. I'm down over 20%, right? That kind of stinks. I would love to have this 0% return at this point. In a recession, it returns 0.05. So it's actually got a positive return in recession. And then in normal times, we're up to 20%. But then what happens in boom times? It goes down. And so what kind of good would you say it is between these two? It's not perfect, but it looks more like this, right? And so maybe we're talking about inexpensive beer. Maybe we're talking about low-end golf clubs. Who knows? But it's obviously not one of these luxury goods. Now, why is that important? Because when the economy changes, it changes the returns of both of these firms and at the same time, right? And if they don't move perfectly together, these ups and downs kind of cancel each other out. And that's what we're going to see is the true magic of diversification, is to have things where these adverse motions kind of cancel each other out. Okay, now let's talk about how we're going to calculate variance and then standard deviation for each of these. So we're going to start out the same way, but the first thing, instead of figuring a historical average, what we're going to do is figure out something called the expected return. So remember, expected return is a SWAG. What does that SWAG stand for? Scientific wild ass guess, right? But I'll tell you what makes it scientific. We have these probabilities and we have these returns given those outcomes. So that's what makes this scientific. So the expected return on the portfolio is equal to, what's that thing? It's a summation. If you're into the sorority fraternity thing, it's a sigma. It's a capital sigma. I is equal to 1 to n. We're going to have n things in this portfolio. Have I lost anybody so far? Okay, so then we're going to have the probability of state n. Oh, sorry, we've got n scenarios. So we've got n probabilities. So in this case, it would be 4. Right? We're not to the, actually, we're going to do this as a return for stock A. Sorry, I'm getting ahead of myself. Okay, the probability of the state of the economy n times the return of stock A in scenario N. Now don't let this freak you out. We're going to work through this so you can see exactly what this means. First of all, what is, we're working on super tech here, what is the probability of the first state of the economy, depression? Yeah, so we're looking at 0.10. You always want to use decimals when you're putting probabilities into an equation, or percentages of any kind. 0.10, and I'm going to multiply by the return, assuming that that state of the economy happens. If that state of the economy happens, super tech is down 30%. Does that make sense? Okay, can anyone guess what we're going to do next? What's the next number we're looking at here? Mr. Bowrichter.
Probability, or wait,
Yeah?
the return,
No, you're, so probability return, what's the next thing we're going to do?
the number. No.
So, Mr. Bowrichter does not know. Mr. Taylor, what do you think we're going to do next?
I'm not sure either.
Okay. I'm going to give someone else a chance. So someone besides Ms. Perry,
Recession.
Mr. Green.
Probability of recession.
Yeah, probability of recession, which we said is 20%. And now I'm going to give Mr. Bowrichter a chance to redeem himself.
Yes, now it would be -10.
Yeah, very good. Okay, plus. Now, Mr. Taylor, what do you think we're going to do next?
I'm lost, I'm not gonna lie to you.
Okay. Let's see. Mr. Fogarty.
Not sure.
Oh my goodness, Ms. Wabi. Okay, so let's talk through this one more time. All we're doing is multiplying these two things together and then adding them all up. So far, we've had the probability of depression, the probability of recession. We've had the return for this stock given a depression. We've got the return for this stock given a recession. Ms. Wabi, did it occur to you then?
Yeah.
What's the next number I should be looking at here?
Wait, so which one are we doing? Super tech or slow?
Super Tech!
Okay, wait. 0.20 times 0.5?
Okay, but you're doing it backwards.
Oh, okay.
Messing with us here. Yeah, so congratulations, that was a good shot. Okay, now, let's see. Mr. Taylor, are you with us now?
Yes, sir.
Oh, very good! What's the probability for this one?
Okay, so 0.20.
Very good. Times what?
Times 0.5.
Yeah, very good, thank you. Whew. See, this is why I learned your name, so I can put you on the spot. Mr. Osawabu, you're next. He says, not until you can pronounce my name correctly. Okay, back to the story. Now we can add these things up. And let's see here. What is 0.1 times negative 0.3? I think that's negative 0.03. Does that sound right? And this one is negative 0.02. Is that right? Okay, and then down here, 0.5 times 0.2, I think this is 0.10. And I think this is 0.10. Does that make sense? Now, if you're doing this on your calculator, which I firmly expect all of you except for Ms. Volkova to do because of how you grew up, right? What would you do? I would do this math, store 1. Do this math, store 2. Do this math, store 3. Do this math, store 4. And then add them all together to get the expected return. So I've got negative 0.03 plus negative 0.02. That gives me negative 0.05 plus 0.1 gives me 0.05 plus 0.10 gives me 0.15 or 15%. Now I want you to look above where it says Super Tech, expected return equals. What does it say? 0.15. Now, did I have to give you that number at all? No. Will I give you that number on an exam? Undoubtedly not, right? No. Don't bet on it, right? Better to be prepared. Okay, so that's how we did that one. So now let's go back and we'll do the same thing only for slowpoke. So what am I going to do? I'm going to erase these numbers and I'm going to erase these returns, but I'm going to leave all the probabilities. Why can I leave all the probabilities? Because they're the same, right? Okay, so now the first one is 0.10. What's the return for slowpoke in depression? 0, right? What's the return in recession? 0.05, right? Okay, what is the return in normal times? 0.20. By the way, why do I put the 0 there? Because sometimes the decimal place gets lost in the fuzz, and that actually was a problem on one of those homework problems that you had for chapter 10, right? The decimal place on the, oh my goodness. And then over here, what's the return in boom? Yeah, negative 0.05. Now, I'm going to show you some mathematical trickery here to make your life easy. Are you ready? Nothing up my sleeve. Right. Okay, so tell me what you notice about these two things.
Same but negative.
Yeah, they're just same thing, opposite signs. So what can I do? They're gone, right? Because you're going to cancel each other out. Now, what do we know about this? Anything times 0 is 0, right? So that's got to go too. So all we're really left with is 0.5 times 0.2, which is 0.10. And so that is our expected return for slowpoke. Now, can someone tell me what it says next to slowpoke expected return equal on the slide? 0.10. Once again, I didn't have to tell you that. You can calculate it for yourself. Questions? Okay, so that's always the first step in any of these things, is to figure out the expected return. Because what we're going to do next is, just like we did previously, we are going to figure out the deviation from the expected return for each of these situations. And so I'm going to start out with my negative 0.3, and then I'm going to subtract the expected return. What was the expected return for SuperTech? 0.15. So minus 3 minus 0.15 is minus 0.45. Is that what the slide says? I think we're there. Okay, and then I'm going to do that for each one of these. So minus 1 minus 0.15 is minus 0.25. 0.2 minus 0.15 is 0.05. And then down at the bottom we have 0.5 minus 0.15 is 0.35. Have I blown your mind yet? Now, so far everything's cool. Now, when we do variance, standard deviation type calculations, the next step is always to square the deviations, and that's what we do in the next column over. And by the way, what happens to that negative on the 0.45 when I square it?
Becomes positive.
Yeah, it becomes positive because a negative times a negative is a positive. So that gives us the 0.2025, and if I square negative 0.25, I get 0.0625. If I square 0.05, I get 0.0025, and if I square 0.35, I get 0.1225. Now, I'm going to share with you something that'll help you understand whether or not you got the whole number. If I square a 2 decimal point number, how many decimal points do I get? 4. If I square a 3 decimal place number, how many decimal places do I get? 6. If I square a 4 decimal place number, how many do I get? 8. Always going to be that way. And so if you're squaring a 4 decimal place number and your calculator says 0.27, something's wrong, right? You've got more numbers out there. Your calculator obviously has not been purified correctly. Okay, now, the very last step in this, and by the way, I'm going to work through all this on the calculator. The very last step in this is the part that trips students up the most. Because what we're used to is adding all together these squared values of the deviation and then dividing by n minus 1, which is what we did in chapter 10. But we're not working with a sample here, we're working with population. And so there is really only a 10% chance that the squared deviation is going to be 0.2025. There is a 20% chance that the squared deviation will be 0.0625. There is a 50% chance that it's going to be 0.0025. And there is a 20% chance that it's going to be 0.1225. So we can come up with an expected value for squared deviation, which, by the way, turns out to be variance. So that's what we're going to do. So what are we going to do? We're going to take the probability of each scenario, multiply it by the squared deviation. That's going to give us that final column over there. We're going to do that for all 4 of them, and then we're going to add all those together, and that's going to give us our variance. Now, if I want standard deviation and I've got my variance, what's the next step I need to take? Just take the square root of it, and now you've got your variance. Does that make sense? Okay, I'm going to walk through this on the calculator, and undoubtedly we'll have to do it more than once, but please pay attention. If you don't have your calculator out, this would be a really great time to get it out. Now, just like I told you last time, I don't want to work column by column. I want to work going straight across, because that way I only have to store one number per line. So I'm going to end up storing 4 numbers here. So here we go. I'm going to take 0.2 times, oh no, sorry, I'm going to start at the very beginning. 0.3 negative minus the expected return of 0.15. That's where we get this negative 0.45. What's my next step? Square it. And so I'm going to hit this button right here. I'm getting the same number we got previously. And then the final number, what do we do? Yeah, multiply by the probability, multiply by 0.1 in this case, equals 0.02025. What do you think I'm going to do with this number? Store where? 1. Very good. Store 1. Okay. Now the next one is 0.1 minus 0.15 equals minus oh crap. Where am I? Let me try this again. Minus, or 0.1. Oh, it's negative. That's why. Minus 0.15. Negative 0.25. What's my next step? Square it. What's my next step after that? Yeah, multiply by the probability. 0.2 equal. So, what do I do now?
Store it.
Store where?
2.
2. Very good. Okay, Mr. Osawagwu, what do you think we're going to do next? Oh, no, we're not there yet. He's thinking ahead. Okay, I'll give you a hint. We're going to start with 0.2, and then we're going to subtract something. What are we going to subtract? Oh, Mr. Osawagwu, I appreciate you coming to my class. You're a good-looking man. But it really works better if you pay attention. Okay. Okay, so what we're going to do here is subtract the expected return. Can you tell me what the expected return is for this stock?
What would you have this stock?
Which one are we working on? The top one.
The top one, so it's 0.10.
The top one.
0.10.
The top one. It's SuperTech.
Yeah.
Yeah? What does it say SuperTech's expected return is?
0.10. 0.10. 0.
No! I'm going to circle it here with the... We all have those days, Mr. Osawagwu. This one's yours. Okay, there we go. That gives me 0.05. Now, I'm going to give you a chance to redeem yourself here. What do you think we do next? So I'm looking at this number right here. What am I going to do with that number next? To get this number right here.
So, just square it.
Yeah, we're going to square it. Very good. Thank you. Okay. Now we've got that number. What's the next step? And I'm gonna stop picking on Mr. Osawogwu here. Is it Ferguson?
Me?
No, we're,
Where?
Fitzgerald, sorry. He's another good Irish name.
Probability.
Yeah, we're gonna multiply by the probability. I knew it was an Irish type name that started with F. So, what's the probability of this one?
0.5.
Yeah, 0.5. Now, what am I gonna do? Store 3, very good. Okay, now, finally, we've got, what am I gonna type next? Ms. Wabi, what am I gonna type next?
0.5.
0.5, very good. And what am I gonna subtract?
0.15.
0.15, very good. She's on fire, we're gonna keep going with her. What do we do next?
Square it.
Square it! And finally, for the quadrifecta here,
Multiply it by the probability.
very good. Thank you. Okay, now, what am I going to do with that number? Store it where?
4.
Very good. Store 4. Okay, now, as I mentioned earlier, the variance is just the expected value of that squared deviation. So that means all we've got to do is add these things up in order to get the variance. So, let's see, Ms. Menace, how in the world are we going to get these numbers back and add them together?
You're gonna hit recall and then the number. that you
Okay.
sorted on.
Recall 1
Plus recall 2.
plus, recall 2 plus, recall 3. She thinks it's so simple, she's not even going to go ahead and humor me by telling me the rest. Okay, so now we've got 0.0585. Is that the number we see on the slide? Yeah. Now, one more step. To get standard deviation, what do we need to do? Yeah, take the square root. So we're looking at roughly 24.19, and you can go ahead and write that number down if you like. In fact, let's see, I'm going to store that as 8. I don't think we're going to get to 8. Store it as 8. Okay. You'll see later that we're going to use that number again. Okay, now let's look at slowpoke. Now that we know how this sort of thing works, see if I can pick on someone else here. Mr. Corbin. Mr. Corbin, what am I going to do down here to figure out, what's my first step? The first number I'm going to type into the computer, or the calculator.
The 0.0.
Yeah, so it'd be 0
subtract
minus what?
Minus 0.15.
Ooh! Is
Or,
that?
Oh, no, 0.1.
I was going to say, ask Mr. Osawogwu, he'll tell you it's 0.10, right? Okay. Now, so we've got negative 0.1 here. What do I do with that number? Mr. Corbin.
Is that when we multiply by the probability?
Oh, we're skipping
I
ahead.
know, I'm missing one step.
You're missing one step. I'll give you a hint. Do you see this right here?
Oh, take the square root.
Yeah. We're going to square it. We're going to square it. There you
That's what I
go.
meant to say.
Yeah.
Almost there, almost
It
there.
happens. Up is
And
down,
then we
left is
multiply
right.
it by the probability.
Very good. Thank you. He's eager to redeem himself. Can't say that to blame. There we go. 0.1. We got 0.001. What should I do with that? Store where? 1. Very good. Okay. That's so Ms. Ware, what should I put in next?
0.05
0.05, and what should I do?
minus 0.10
Minus 0.1 equals
square,
square. Very good. And then?
multiply by the probability.
And the probability is?
0.2.
0.2. And now, Ms. Ware, what should I do?
Store 2.
Very good. Store 2. Okay. I'm getting ready to pick on someone else. Who will my next victim be? Ms. Neuenschwander. I know you're probably 2 sheets to the wind by now, but...
You'll do, let's see, we just did 0.05.
Uh-huh.
So 0.20 times, or sorry, minus 0.10.
Uh-huh.
And then you square it.
Yeah. And then what do I do?
And then you're gonna multiply by probability, which is 0.5.
Very good. And then what will I do with that number?
You're gonna
Yep, store 3. Very good.
Now I have to go back and do it in my calculator.
Well, go ahead. You could play along at home while we're. Ah. Okay. Mr. Fisher. Yeah. He's like, oh crap! There were 8 shots here and 29 students. I was thinking I'd get away with it. So, what do you think we're gonna do for that last one?
For that last one, we'll do, negative 0.05
Very
minus
good.
21.
0.05 negative minus 0.1. Very good. You got the right number. What do we do next?
Square that,
Square it, and then what do we do?
multiply it by 0.2.
Okay, because that's the probability, and that gives us 0.0045. What do we do with that number? Store 4. Very good. Yeah, I thought you were going to fall down on that one, but I'm very impressed. Very impressed. Okay, Ms. Craybill, what are we going to do next?
Add, or I guess for call 1,
Uh-huh,
plus for call 2,
uh-huh,
plus for call 3,
uh-huh.
plus for call 4. Equals.
Very good. Now, I've got a variance of 0.011. Mr. Fogarty, if I'm with the standard deviation, what should I do?
Take the square root.
Very good. Take the square root. Mr. Fisher's thinking you got off easy. Okay, so we stored that other one in 8. I'm going to store this one in 9. Now, knowing what you know about standard deviation, which one of these stocks is riskier? Remember, the standard deviation on the first one was 24.19%. This one's 10.49%. Which one of these stocks, held by itself, is riskier? Yeah, the first one has to be standard deviation higher. Remember, we said standard deviation is our mathematical measure of risk. You guys remember that? Okay. Now, I also want you to look at the expected return. The expected return of the riskier one is higher. Does that make intuitive sense to you? Yeah. Okay. So far, nothing really shocking here. By the way, do you think you guys need to go back and practice this like 14 times? Well, maybe just 13. You need to practice it because even though right now you're sitting here thinking, oh, that looks right, it will escape from you. Okay. So now what we're really interested in is how these things move with respect to each other. Because remember, I told you when you hold things in portfolios, it matters whether those things move together or whether they move in opposite directions. And so that's what we need to look at next. And we have 2 mathematical measures of how things move with respect to each other. The first is called covariance, which is very closely related to variance. I'll explain why here in a minute. And the other one is going to be called correlation. Correlation. Okay, now, how are we going to figure these things? Well, we're going to set up our same states of the economy. That one all makes sense. And then, instead of taking the deviation for one stock and squaring it, we're going to take the deviation of one stock and multiply it by the deviation of the other. And in fact, you can think of variance just being the covariance of a stock with itself. You can think of variance as just being the covariance of a stock with itself. Because if I were comparing SuperTech to SuperTech there, I would have negative 0.45 times negative 0.45, which is just negative 0.45 squared. And so if I do this covariance calculation using comparing a stock to itself, that gives me variance. So variance is just a very special case of covariance. Okay, let's see what else I can tell you. So now we're going to multiply those things together and get product of deviation. So instead of squaring, we're going to get the product of those deviations. And that's going to lead us to something new and interesting. And that is that we can have a negative in that column number 5. When we're squaring, was it possible to get a negative? No, because negative times a negative is always positive. Positive times a positive is always positive. All those squared deviations are going to be positive. But when we start to look at these product of deviations, now it is entirely possible for these things to be negative. And it has a meaning to it. And the meaning is if that particular scenario is negative product deviations, it means these things are going in opposite directions. Either A is negative and B is positive, or A is positive and B is negative. Got to be that way. That tells you they're moving in opposite directions. Okay, so now we've got that product of deviations, and then just like we did for variance, we're going to take the probability of the state of the economy, we're going to multiply by that product of deviations, and that's going to give us column 6 out here, which is the product of the probability and this product of deviations. Now when I do that, I'm going to take column 6, which is the expected value of the product of deviations, and I'm going to add it all together. And when I add it all together, the number that pops out is not going to be variance, it's going to be covariance. It's not going to be variance, it's going to be covariance. And note, in this case, it's negative. It's negative. Could variance ever be negative? No, because you always got negative times negative or positive times positive. It's always going to be positive, but in this case, it's negative. Now, what does a negative covariance tell me? It tells me that these things have a tendency to be moving in opposite directions. They have a tendency to be moving in opposite directions. But I can't tell you anything really great about the magnitude because covariance has the same units as variance. Does anyone remember what the units of variance were? Something squared. What was it? It's percent squared, right? And so percent squared, we said, we don't know how to interpret that. So we don't know how to interpret this 0.001. And so after we get through calculating all this, I'll show you how to do that. And then I'm going to show you what we're going to have to do with that covariance number in order to be able to interpret it. So, does everyone have their calculators out and ready? Okay, get your calculator up. I'm going to hit clear. And in this case, what I'm going to start doing is just multiplying the deviations together to get this product of deviations, and then I'm going to multiply that product of deviations times the probability to get column 6. Okay, who have I not picked on? I know this is going to be confusing. Mr. Herberholt.
Which one?
I'm going to start with the vacationer. Ah, there you go. What do you think is the first number I should put in here?
001.
Oh, you're jumping way to the end. So what's the first step we're going to do here? I said we're going to take these things and come up with the product of deviations.
Then 0 or 0.45.
Very good. 0.45 times what?
0.10, negative 10.
Okay, so you got to be careful here. You gave me positive first, and I was willing to play along.
Oh, so I should have stayed positive.
You should either stay positive or you
Yeah.
should be, stay positive, man. Okay. So the trick is, first of all, I'm lazy. Secondly, I make mistakes. And so when I see a negative times a negative, I know it's going to be positive. Do I even type any of the negatives? No. And that was your first instinct, but then you strayed into the
Yeah.
bushes. Yeah, okay. So now what do, other Mr. Herberholt, what do you think we should do next?
Multiply by 0.10.
Yeah, multiply by 0.1, and that gives us this last number. What should we do with that? Mr. Osawoglu, what do you think we're going to do with that number? Right here. What are we going to do with that number?
So it said the probability multiplied by the product of.
Okay, we already multiplied the product of deviations times the probability. That gives us this number right here. So we are at the end. What should we do?
Store.
Yeah, store where?
1.
Very good. Store 1. Clear. Mr. Bowrichter, what's next?
0.25 times 0.05.
And why could we leave the negatives off?
It's going to be positive.
It's going to be positive anyway. We get the same number. And then, I know there's someone I have not picked on yet. Ms. Bergner. Ms. Bergner, what should we do next?
And you multiply by the probability, so 0.2.
Yeah, very good. 0.0025. What should I do with this number, Ms. Bergner?
Store 2.
Very good. Okay, Mr. Green, what should we do next?
You're multiplying
0.05,
Mhm.
0.10.
times 0.10 equal. What do we do next?
Multiply by the state, probability of state economy, 0.5.
Okay. And then what do we do? Store 3. Raise your hand if I haven't picked on you yet. Oh, very good. Let's see, now I can't remember where we were at. Which one did we just finish? The third one. Mr. Greeley, what should we do next? 0.35 times, oh, and did you hear what he said? Times negative. Why do we have to go ahead and put the negative sign in, Mr. Greeley? Yeah, exactly. And so now I've got this minus 0.0525. Mr. Greeley, what do I do next?
And then you'll multiply it by 0.2.
Multiply by 0.2 equal, and I've got minus 0.0105. What do I do now? Store 4. Store 4. Okay, now let's see who else I haven't. And for some reason, your name escapes me. What's your last name?
Kilby.
Kilby. I should know that by now. I'm sorry. And I even have on my notes here that you have a beard. Yeah. If you ever shave.
I thought about shaving it.
Yeah,
because you said that last
it would
time.
just jack with me if you did. So of course that's probably what you'll do. Okay, so Mr. Kilby, now we have all these numbers. I hope we have all these numbers in our storage. What do we do?
We're gonna add them all up.
Yeah. So how are we going to do that? Tell me key by key.
Recall.
Recall 1
Plus. Recall 2.
recall 2
Plus.
plus
Recall 3.
recall 3 plus.
Recall.
I think we have a problem here. Did you see recall 2? Recall 3. Okay, we don't have a problem, sorry. Recall 1 plus recall 2 plus recall 3 plus recall 4 equals minus 0.001. Is that what we're supposed to get? Yeah, that's the covariance of these things. They move in opposite directions, but once again, we don't know the extent of that. It's percent squared. We can't interpret it. So what we need to do is take it to a number that we can interpret. Now, when we were going to take variance to a number we could interpret, how do we go about that? We took the square root, right, to get it into standard deviation. What happens if we take the square root of minus 0.001?
Get an I.
You get an I. And what does I stand for?
Square root of -1.
Okay, so the square root of -1 is something called I. And it is known as an imaginary number.
My favorite imaginary number.
It's your favorite imaginary number. What other imaginary numbers do you know of?
I can't remember.
Exactly.
But
This
it's
is-
also because my high school teacher had like a song about swearing and stuff.
We won't ask you to sing that, right? I appreciate you bringing it up. Okay, so imaginary number. And so what we would get here is actually something called a complex number, which is, this is stuff they should have taught you in math. So a complex number has both a real portion and an imaginary portion. Now, when I was in the College of Engineering, we said the College of Engineering was very complex because we had both real disciplines, mechanical, chemical, civil, and imaginary disciplines, industrial engineering. Do you know what I spent most of my career doing? I was a mechanical engineer doing industrial engineering work. Okay, so there's your today's math lesson and your bad engineering humor. Okay, so what do we need to do then? We can't take the square root of this thing. We're going to have to find some other way. And so what we're going to do is calculate the correlation. So there's a nice formula there at the bottom. By the way, if there's a formula on the slides, what should you do with it? Yeah, put it on your note sheet, right? Okay, so correlation of stock A with stock B, in this case, Supertech with Slope Hope, is equal to the covariance of stock A with stock B divided by the product of the standard deviations of those two things. Now, here's something I want you to think about. I just told you that covariance has units of percent squared. What's the units for standard deviation? We said variance is in terms of percent squared. How do we get from variance to standard deviation? Square root. What's the square root of percent squared? Percent, right? So standard deviation is in terms of percent. So if I take percent squared, divide by percent times percent, what happens to the units? They all cancel out. Correlation is unitless.
Wow.
Correlation is unitless. And you say, way to go, moron. You've taken us from something with units to something with absolutely no units whatsoever. How in the world does that help us out? I'll show you. But first we'll calculate the number, then I'll show you. Okay, so remember we have covariance. It should be still in our calculator. Oh, come on. There it is. And I saved those two standard deviations. Remember that? So I'm going to say divide by, open parentheses, recall 8 times, recall 9, close parentheses, equals. So now I'm getting minus 0.039. Minus 0.039 still doesn't mean anything to you until we show you what correlation looks like. So covariance is not bound. It's not limited. So it could go all the way that way, it could go all the way this way. But it turns out the correlation is bounded on the upper bound by the number 1 and on the lower bound by -1. And here in the middle is 0. And if something has a correlation of 0, it means that the action of one of them has nothing to do with the action of the other. There's really no relationship between their movements. Okay, so where does my minus 0.04 basically fall on this scale? Just to the left of 0. Right about here. Here is our minus 0.0394. So if I ask you this, is this thing closer to being perfectly negatively correlated or being uncorrelated? What's it closer to? Yeah, it's closer to being uncorrelated. This is why calculating the correlation helps us to understand the relationship. We can interpret it, whereas we could not interpret covariance. We could not interpret covariance, yes?
What is it? Why are you doing to the power of 0.5 up there?
Oh! To the power of 0.5 is the same as the power of 1/2, which is precisely the same as square root. And so those numbers that you see there are variance, and we're taking the square root of the variance, gives us a standard deviation, but I had them stored in my calculator. Good question. That's why I stored them in my calculator, because I didn't want to muck with that.
Is there any reason to do it that way instead of just using the square root of the values from earlier?
No, perfectly fine to use the square root of the values from earlier. This is like the 14th time I've taught this, no, maybe 28th time I've taught this. And so that's why I knew to go ahead and store those numbers, because I knew where we were headed with it. So, by the way, when you guys calculate stuff like that, and you've got spare space in your storage, store 8, store 9, if you don't need it later, not a problem. If you do need it. What's better, storing stuff or writing it down? Storing stuff. Give me some reasons. Rounding error, number 2. Mistakes. And there are mistakes in 2 directions. There's the mistake of me writing it down, and then there's the mistake of me punching it back in. By the way, raise your hand if you're perfect, other than Miss Perry. Raise your hand. Nobody. Oh, you think you're perfect? No, he's messing with me. And by the way, he has a beard. Okay, so back to the story. I don't know why I can recognize you without writing beard on the sheet. I've really got a Kilby, right?
Yeah.
Very good. Okay.
I might be on the test, I'm not.
Ooh, she just confessed her grade. Everyone cover your ears when people confess their grades. That's a violation of FERPA. Actually, it's only a violation if I tell them. You
Yeah.
feel free to tell them, yeah. So I was teaching this China EMBA class, and I always, after exam 1, I would seat the lowest scoring people on the first row, the second scoring people on the third, and so, you know, so they're all the way up. Everybody's looking at someone who did worse than they did, right? Since I'm not giving you a seated test, I can tell you my secret, right? And so these people, they figured it out. And they said, that's really an invasion of our privacy. And I'm like, what? And they said, you seat everybody where they're looking at someone who scored lower than them, so we know who scored worse. I said, how do you know? And she says, because we tell each other all our scores. I'm like, then how the hell is where I set you in any way, shape, or form a violation of your privacy? Okay, so in the whole scheme of things, this thing, we're looking at something that's really not all that correlated. And we just talked about all that. So now let's talk about some different correlation examples. And over here, we have what we call perfect positive correlation. And over here, we have perfect negative correlation. And here we have uncorrelated. Now, let's talk about what those things mean, because there's a simple case for both perfect positive and perfect negative that's really easy to catch. So here we go. Are you ready for more interpretive dance? If this one's up 1% and this one's up 1%, and this one's down 3% and this one's down 3%, and this one's up 1% and this one's up 1%, they are perfectly positively correlated. That's easy, easy, easy. But let me give you another example of perfect positive correlation. This one's up 1%, this one's up 3%. This one's down 1%, this one's down 3%. This one's up 2%, this one's up 6%. This one's down 3%, this one's down 9%. They're still perfectly positively correlated. And all I would have to do, well, we'll get to that in a minute. So here's the trick. How can I tell whether something's perfectly positively correlated? If I take the deviation of one and divide by the deviation of the other and always get the same positive number, they are perfectly positively correlated. If I take the deviation of one and divide by the deviation of the other, and for all cases, they always give me the same positive number, they are perfectly positively correlated. Now let's talk about perfect negative correlation. The simple case, of course, down 1%, up 1%. Up 2%, down 2%. Down 3%, up 3%. Right? Easy, easy, easy. But what about this? Down 1%, up 2%. Up 2%, down, see, what did I say, 1 and 2? Yeah, down 4%. As long as I can divide one of the deviations by the other and always come up with the same negative number, then they are perfectly negatively correlated. If I can divide the deviation of A by the deviation of B and always come up with the same negative number, they are perfectly negatively correlated. And then we have the final thing, which is zero correlation. Zero correlation. That means that the movement of one has nothing to do with the movement of the other. The movement of one has nothing to do with the movement of the other. I will tell you, in this world, there are very few things that display a total zero correlation. And I was given this example one night in a night class, and I had two guys from Ghana there. I think they're called Ghanaians. But anyway, we were talking about correlations between different economies. And I mentioned that the United States and China, because of our economic relationship, we are positively correlated. If the United States is doing better, we buy more stuff from China. If the United States is doing worse, then we buy less stuff from China. So there's positive correlation there. Then we have Russia. And this was back before the fracking discovery. And in fact, I think we're back now pretty much in the same situation that we were before. And that is that high oil prices benefit Russian economy, but they hurt the U.S. economy. Does that make sense? Because they are a huge oil exporter. And so you would expect those two economies to be negatively correlated. And I made the statement that I don't think there are any economies that are uncorrelated. And the Ghanaians said, well, we are. And I said, why? And they said, well, we only have two real exports. We've got gold and chocolate. And We sell the gold to the Chinese and the Indians, and we sell the chocolate to the Europeans, so we don't have anything to do with you. I said, where do you think the Chinese get their money to buy the gold? Right? We're buying stuff from China, they're turning around. So my point to you is this. Finding zero correlations in the real world, very, very difficult. Questions? Okay. So now let's talk about how we're going to calculate the expected return for the portfolio. By the way, we said expected, anytime we hear the words expected return, we know it's a swag. So are we sure this is the correct number? No, it's our best guess. And what we're going to do here is we're going to find the expected return on the portfolio is equal to the probability of any of the scenarios multiplied by the return on the portfolio in that scenario. That's how we're going to find the expected return. But, oh shoot, sorry, I am getting ahead of myself here. I'm gonna erase that, forget that I said that, I will cut it out of the video. So let's talk about this. Expected return, we're not to the probability part, we've already done that. What we're gonna do here is we're gonna take the weights of the things in the portfolio. The weights of the things in the portfolio. And it turns out that we've got $60 worth of SuperTech and $40 worth of Slowpoke. And that's everything in our portfolio. Can anyone tell me the total value of the portfolio? Mr. Umfleet, I don't think I picked on you today.
I don't think you have.
You didn't, did you raise your hand when I asked if you'd been picked on?
You had already picked somebody.
Oh, so he was one.
You went too fast.
All right, yeah. Okay, what's the value of the portfolio, the total portfolio?
$100.
100, very good. And so now we're going to come up with what are called portfolio weights. And how are we going to come up with the portfolio weight? We're going to take the individual value of each thing in the portfolio and divide by the total portfolio value to come up with the weight for that thing. So Mr. Umfleet, can you tell me what the weight on SuperTech should be?
On SuperTech, that would be 0.6.
0.6, and how did you get there?
60 divided by 100.
Very good. And the portfolio weight, good luck on your interview. The portfolio weight on Slowpoke, what should it be?
0.4.
0.4. And you came up with that as 40 divided by 100. Okay, now let's ask Mr. Taylor. If you add 0.6 and 0.4 together, what do you get? 1. It's always going to be the case. It's always going to be the case that when you add the portfolio weights together, you should get 1. If you don't, you've done something wrong. If you don't, you've done something wrong. Now, some students will take that piece of information and they'll say, aha! All I have to do is figure the weight on A, and then I just take 1 minus that to get the weight on B. You are missing a vital opportunity to check your work, right? Figure the weights independently, then add them all together to make sure that they work, and they add to 1, and if they do, you're good to go, and if they don't, you need to go back and look for your mistake.
That's much I can see you being pro and adding a third stuck in there, but only having us calculate the 2.
Ooh, very good. So more likely, I would tell you it's a $100 portfolio, you've got 30 of A, you've got 60 of B. What have I not told you? C. And how are you going to find C? You got to subtract, right? Oh yeah, she's absolutely right. I am cruel, 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 which means you need to practice, practice, practice. Okay, back to the story. Now we have the weights. In order to figure out the expected return on the portfolio, all it is the weighted average of the returns of the individual components. Now, we just figured the weights. All we got to do is take the weight on A times the expected return of A plus the weight on B times the expected return of B. Now, what if we had, as Ms. Perry says, what if we had 3 things? What would this formula look like? There would be one more term. What would it be? Plus X sub C times expected return on C. Does that make sense? Okay, but all we're doing here is a weighted average. All we're doing is a weighted average. So we're going to put all this stuff in here, 0.6 multiplied by that expected return on SuperTech, which we said was 15%, and then add the weight on slowpoke times the expected return on slowpoke, which was 10%. So for those of you who can't do the math really quick, I'm just going to tell you that's 9% plus 4% gives us 13%. Now it makes all the sense in the world that the return on the portfolio, the expected return, is going to come out somewhere between these two. Because after all, it is a weighted average. If I give you a 2 and a 4, and I ask you to come up with some sort of average between the two, it's always going to be somewhere between them, right? So that makes all the sense in the world. Okay. Now, where do we get expected return on A and B? Well, we calculated it if we have those probabilities and expected returns. In the real world, do you think we have those? No. We're going to use historical average as our expected return in the real world. And so when you see someone out in industry talking about the expected return on a portfolio, they're talking about historical returns. Now, what does every disclaimer for every investment company in the United States have to say? Past performance is no guarantee of future results, right? But it is our best guess. Does that make sense? Okay. Now we're going to look at the variance of a portfolio, and this is where it gets hairy. So what we just did was very simple. It's just a weighted average. Now we're going to look at the variance for this 2-asset portfolio, and it's going to go as follows. It is XA squared. What is XA? The weight on A, right? It's going to be the weight on A squared multiplied by, what is sigma squared sub A? Yeah, it's the variance of A, which is the standard deviation of A squared, same thing, plus XB squared, the weight on B squared, times the variance of B, plus 2 times XA, XB, covariance of A with B. That's what that sigma, if you see a sigma with just one letter after it, it's standard deviation. If you see a sigma with a something comma something, then it's a covariance. Don't let the sigma freak you out and think that this is a percent unit. It's not. It's just like variance. It's going to have percent squared units just like variance. Okay, now, so far this usually blows students' minds because it seems rather complex. But let's talk about what would happen if you had a 3-asset portfolio. So let's give that a shot. Are you ready? XA squared times the variance of A squared plus XB squared times the variance of B, sorry, I don't mean variance squared, times the variance of B plus XC squared variance times variance of C plus 2XA XB covariance of A with B, 2XA XC covariance of A with C, and 2XB XC covariance of B with C. That's just with
It's like
3.
the alphabet.
Oh yeah! Oh, it gets worse, right? By the way, we can only have 26 pieces in our portfolio because we only have 26 letters. That is total bullshit. That is totally not true.
They're going AABB.
Oh yeah, she's going with the AABB, and I get
That always
that.
start using other languages.
Oh, very good.
Chinese
So-
characters.
So I have a new colleague, and so she was asking for my contact information because we were going to text about a dog sitter. And she says, I start to tell her my info. She's like, oh, just type it in. She hands me her phone, and I'm like, is that Arabic? And she says, no, it's Farsi.
Oh.
And it turns out Farsi and Arabic are written in the same script, right? I said, do you really think that I'm going to be able to spell my name out with that? She's like, I'm sorry. Here you go. Okay.
Greek in mine.
What's that?
I have Greek in mine.
Yeah. The problem with Greek is when you start throwing in Greek letters, now what do people think we're talking about? They start thinking about covariance and variance and those sorts of things. Yeah.
I have it because of sorority and fraternity.
She's a sorority girl. Okay. Can you guess whether or not I was in a fraternity or sorority? Well, you can probably guess I wasn't in a sorority, right?
I mean, you could have been.
I was an engineering student. I didn't have time for that. I had to have my wife actually came to my room. That's how I met her, right? I wasn't out like looking because I didn't have time.
There are many organizations that are
What's
both
that?
sex. There are many organizations that have both sex on them.
Oh, okay, so in 1989, do you think that was true?
Yeah. Gamma Sigma Sigma.
Not at the University of Arkansas. Okay, back to the story. So, what do we do here? We're going to find this variance of the portfolio. We need to put the numbers in. The variance of A was 0.6, so we're going to square that. So let's get the calculators out and make this happen. And I'm going to break this down into three pieces. So we're going to say 0.6 squared times 0.0585 equals. What do you think I should do right now? Yeah, store 1. Clear. 0.4 squared times 0.011 equals. What should I do with that? Store 2. And then 2 times 0.6 times 0.4 times 0.001 negative equals. What should I do with that? Store 3. Then if I want to get the variance of the portfolio, what should I do? Recall 1 plus recall 2 plus recall 3 equals 0.02234. Now, someone asked earlier, what does 0.5 to the 0.5, is that you? Did I ask about okay, can you tell me what we should do next?
Square root.
Yeah, we're going to hit the square root button. And that's going to give us the standard deviation. So the standard deviation here is 14.95%. 14.95%. And if you think back, we had the standard deviation for Slowpoke was 10.49, and for SuperTech was like 24.19. Kind of makes sense that this is somewhere in the middle. Kind of makes sense, but we're gonna show you later that it doesn't necessarily have to be. So the question is this. Remember, we found the expected return being the weighted average of the expected return on the portfolio was the weighted average of the expected returns on the individual pieces. Do you think that the standard deviation of the portfolio is merely the weighted average of the standard deviations of the components? Let's find out here. If we take 0.6 times the standard deviation of A plus 0.4 times the standard deviation of B, we get that one long number there, 0.187, which is 18.71%, which is actually more than our standard deviation that we calculated for the portfolio. And here's the reason why. If we do the weighted average of the standard deviations, it doesn't take into account how these things are moving with respect to each other. And so we're able to actually get rid of some of that risk by holding these things together in a portfolio because they don't move perfectly together. And we call that the magic of diversification. So here's the trick. If I have a portfolio and I can go out there and find any single stock that is not perfectly positively correlated with that portfolio, if I add that stock to my portfolio, I am going to get rid of some risk, but I am still going to get the weighted average expected return. And so it's like having your cake and eating it too. You're getting the return, which is the cake. Well, I guess they're both cake in this case. You're getting the return, but you're getting rid of some of the risk, which is also a good thing. Does that make sense? Okay. So I'm going to show you how this works. We're going to take this variance formula that we've been talking about, and we're going to rearrange it. Remember earlier I told you that covariance, or the correlation of A with B, was covariance of A with B divided by standard deviation of A times standard deviation of B. I didn't do it in Greek. That's the Greek right there. That Philadelphia Phillies thing is rho, right? Okay, so rho A comma B, that's correlation. sigma A comma B is covariance, sigma A is standard deviation, sigma B is standard deviation. Okay, now I'm going to solve that thing for covariance of A with B, and it actually turns out to be correlation of A with B times standard deviation of A times standard deviation of B. And I'm just going to substitute that back in. And so now we get that formula on the bottom. And you see the only thing that's different is out there, instead of saying covariance of A with B, it says correlation of A with B times standard deviation of A times standard deviation of B. Only difference. By the way, should this be on your note sheet? Yeah, and you need to read carefully when you're doing these, because I could give you covariance or I could give you correlation, right? You need to read carefully. Ms. Wabi, I could see the stress headache building up there. Practice, practice, watch the video again. By the way, should you watch my videos late at night or when you've been drinking? No, especially
Could be a good drinking game.
I have actually had students tell me that. And when I told them that, they said, yeah, we watch your videos and we have a drinking game, but they never told me what the trigger was. Okay. Yeah, probably every time I say something stupid. Which might have been why those students didn't do so well in my class. Okay. So, now, if we put all these numbers back into the equation, and I'm not going to drag you through all these, but if I do all that out with a perfect positive correlation, it turns out that I get that weighted average standard deviation. In other words, the only way I don't get diversification benefit is if they are perfectly positively correlated. That's the only way I don't get diversification benefit. Students often think, well, they need to be negative correlated. No! Correlation to 0.99, I'm still getting some benefit. And so don't let that freak you out. And in fact, here's a great test question. Are you guys ready? What's the best correlation for diversification? And the answers are +1, 0, and -1. We know the positive one's not the answer. What do you think's the most common answer? Should be -1, but the most common actual answer is actually 0. Why? No idea. I would rather have -1. If I could do this, and I'm going to prove this to you later, if I could do a perfect negative correlation, I could have the weighted average of the expected returns of the individual components and no risk. That would be sweet. By the way, spoiler alert, it never happens. Questions? Okay, I'll see you next time.